Hey, what's up guys? Welcome back to our YouTube channel, Nath Online Classes. Today once again I am Vidyasagar is present in front of class 10 to discuss subject chemistry with all of you. So please like the channel, share and subscribe it. Let us start the discussion. Before starting the discussion, we want to ask a question to you that do you know the other allotropes of carbons other than diamonds and graphite? Do you know what is buckyball? And do you know why the large amounts of compounds formed by the carbon atoms? Do you know the catenations? So please think and answers about it. Now let us come to know about it. First of all, I am going to discuss about the other allotropes of carbons, that is fullerenes. Fullerenes is one of the another allotropes of carbons. In 1985, one scientist whose name is Buckminster Fuller from America stated another types of allotropes of carbon that is formed by the 60 carbon atoms. Its name is fullerene. In the respect of it is named in the respect of the scientist of Buckminster Fuller. Okay, actually this fullerene contains of 60 carbon atoms in its molecules, which is interlocked to each other either with pentagons structures or hexagonal structures. If it is interlocked with hexagonal structures, then 20 hexagon structures are there in one buckyball, and if it is interlocked with pentagon structures, then there are 12 pentagon structures are there in one buckyball. What is buckyball? It is the interlocking of carbon in fullerenes. It looks like a football. Just you look like a football. The buckyball looks like similar to a perfect football. Okay. So this is called as buckyball or geodesic domes. It is here represented. It is a pentagonal structures. It is formed by the 12 pentagons of carbon, and it is formed by the help of 20 pentagons of carbon. It is formed one fullerene molecules contains 60 carbon atoms that is formed by 20 hexagons and 12 pentagons atoms. Okay, so you have to remember this buckyball looks like a perfect sphere or simply like a football. Understood? Here you can look, there is 6 pentagons. Here there are 6 pentagons structures of carbon atoms, and here hexagonal carbon atoms. Hexagonal structure of carbon atoms in this buckyball, and in one molecule of fullerene contains such types of 20 hexagons and 12 pentagons atoms of carbon, and such types of buckyball contains 12 pentagonal structures and 20 hexagonal structures. Here I used to show by using pentagon structures of carbon atoms, and here I used to show hexagon structure of carbon atoms. So you have to try to understand it clearly and try to remember all these things about fullerene. So these are the another allotropes of carbon. Now I hope you have known about the another allotropes of carbon other than diamonds and graphite. So remember these things. Now look at what I have done. I have asked you, can you tell why the carbon atoms contains a large amount of compounds? So please concentrate on this video and try to know the answer. And one question also I have asked you about what is catenations. Catenations is the properties to make the molecules by sharing of bonds with same atoms, and carbon is the element that shows more catenations in comparison of the other atoms. So the main cause, the main reason to have a large amounts of compounds, once again try to understand please what I have asked you. I have asked you why carbon atoms contains large amounts of compounds. It is due to the following reasons. Carbon shows the properties of catenations. It has the tendency to form carbon-carbon bonds, that is called as catenations, and it has the tendency to make a chain. There are three types of chain: a straight chain, and branched chain, and closed chain. And second cause of the second reason why the carbon has a large amount of compounds is tetravalency of carbons. Third is tendency to form multiple bonds. So please let us explain it one by one. Here I have written, this is the unique property of carbon to have the large amount of compounds. First reason is tendency to form carbon-carbon catenation. Catenation is the property of elements to form a bonds with atoms of same elements. To form a bonds with the atoms of same elements is called as catenations. This property is shown by carbon, and the formation of bonds takes place between carbon-carbon atoms is stronger than the bonds formed between the atoms of carbon and other atoms. Understood? The formation of bond form is stronger than when it is formed between carbon-carbon atoms and it is stronger than other bonds that is formed between carbon and other atoms. Understood? It has self-linkage from strong bonds, as I have told you about it, and it forms different types of chain. It has 4 tetravalent. It has 4 electrons in its outermost shell, as you know. So it can form the bond with 4 carbon atoms. In this way, it make a straight chain or branch chain or closed chain. Example of a state chain is such types. Example of branch chain is such types. And example of closed chain is such type. Now try to understand. Here one carbon atom has 4 bonds, 1, 2, 3, 4. Now this bonds is formed with these carbon atoms. This also has 4 bonds, 1, 2, 3, 4. This bond is shared between 2 carbon atoms. This is also shared between 2 carbon atoms, 1, 2, 3, 4. This is also shared between 2 carbon atoms, 1, 2, 3, 4. So each carbon atom has 4 bonds here. Due to this, and this is a long chain. This can be stretched infinitely. Okay, so this long chain is the region the number of compound is large. Not only a straight chain, but it can form some branch chain also. This is another compound and this is other compound. Here number of carbon atoms is 4. Here number of carbon atoms is 4. In both the compounds there are 4 carbon atoms, but you know about it further that they are different compounds, shows different properties. And here look, there are 6 carbon atoms. This types of compound is also called as compounds of carbon, but shows the different properties because it has closed chain, due to which we can say that the carbon has large amount of compounds. As you know, it is wonderful to hear that carbon atoms, the compounds formed by the carbon atoms is approximately equal to 3 millions. 3 millions compounds. So you should remember and know about it more and more. Now, after catenations, I am going to explain about the tetravalency of carbon. This is another reason, that's why the compounds of carbon are large in numbers. So let us look what is the tetravalency nature of carbon. Tetravalency means it forms 4 bonds because number of valence electrons in carbon atoms is 4. That's why it can share its 4 electrons with other atoms or same atoms. If it share 1 electrons with other atoms, then 1 bond is formed. And if it share 4 electrons, then number of 4 bonds are formed. This formation of 4 bonds is called as tetravalency of carbon because it can form 4 bonds with same or different atoms. As for example, you can look in the methane. Here 1 carbon atom can share its electrons with 4 hydrogen atoms, so that the formation of methane takes place, as it is shown here in the figure. Since the valency of carbon atom is 4, the number of bonds formed by carbon atom is 4. The example is methane. Here 4 atoms of hydrogen are combined with the carbon atoms by sharing 4 electrons. 1 electrons of hydrogen and 1 electrons of carbon shared here to complete its octet. And these types of bond formed by the sharing of carbon and hydrogen atoms is stronger than the other bonds because the atomic size. Since carbon has a small atomic size, the nucleus of carbon has large force of attractions to the other electrons. That's why I have written here it forms a stable strong bonds due to its small size, nucleus of carbon atoms holds the shared pair of electrons strongly. Nucleus of carbon atoms can have the stronger effect with the other shared pair of electrons. So this is the tetravalency of carbon. That's why the large number of compounds formed. Another reason why the carbon atoms has large amounts of compounds is tendency to form multiple bonds. Same carbon electrons can share single electrons, double electrons or triple electrons with other elements. That's why it can form single bonds, double bonds or triple bonds. As you can see, it happens due to a small size of the carbon atoms. In ethane, here the formation, a structural formula of ethane, here the formation of compounds takes place with the share of single electron. Here only one electron is shared with hydrogen atoms. That's why the single bond formed between carbon and hydrogen. But here there are two electrons is shared between carbon and carbon atoms, and one electron is shared with two hydrogen atoms. Here you can see in this structure formula, here between carbon and carbon atoms there are two electrons is shared. That's why the double bond is formed. So ethylene forms by the sharing of two electrons between carbon atoms. That's why it forms double bonds. In the case of acetylene, you can see acetylene or ethine. It is also called as ethine. Its IUPAC name. You will read about it in the next upcoming video. Ethine, here there are three electrons are shared between carbon and carbon, and one electron is shared with hydrogen. So 4 electrons of carbon is shared with 3 electrons of carbon and 1 electrons of hydrogen. Then that's why the formation of 3 bond takes place, and here 1 bond with hydrogen takes place. So carbon atoms can form in this structure. There are 3 bonds. That's why we can say that the same carbon atoms can single bond, double bond or triple bonds results to form a different compounds. That's why the number of compounds becomes large and large. So you have to understand these things, and you have to remember after understanding it well. Note, if carbon compounds are linked with single bond, then it is called as saturated compounds. As for example, ethane is saturated compound. But if the carbon atoms forms double or triple bonds or more than single bonds, then it is called as unsaturated compound. As for example, ethylene and acetylene are unsaturated. It is unsaturated. Unsaturated. It is also unsaturated. But it is saturated. It is saturated compound because it has single bond. It has double bond. That's why it is saturated, unsaturated. And it has triple bond. That's why it is also unsaturated compound. So these are the explanations about why carbon has large amounts of compounds. In this video, this is explained. One thing you should also know, this is the reason having large amount of compounds, there is separate branch of carbon to be studied. Okay, and the unique characteristics feature of carbon such as catenations, tetravalency and other things. Due to this, carbon having large number of compounds, and the compounds which has the carbon atoms, and the study of this compound comes under organic chemistry. So the organic chemistry is the branch of chemistry that deals the study of carbon and its compounds. Earlier it was supposed that only living things contains organic compounds, but a scientist whose name is Friedrich Fuller in 1828 gives a great setback to these considerations that not only living things but non-living things also have organic compounds, when he showed by preparing a compounds called urea in the laboratory by the synthesis of nitrogen sulfate, ammonium sulfates and potassium cyanate. When ammonium sulfate and potassium cyanate is synthesized in the laboratory under proper conditions, then the formation of urea takes place. Okay, after that it supposed that not only living things but non-living things can contain organic compounds. So it is explained in the next video. This comes under the organic chemistry. So please first remember all these things. In the next video I shall come meet again with some other explanation. Till that I want to say goodbye. Thank you. See you.